very very important combination, that is parallel combination. So please make every student thorough with in-text numericals, textbook, end of the textbook in the exercise, numericals are there. In-text numericals, worked out examples and thorough all textual questions. These three numericals must be thorough. Give practice twice or thrice. They must be thorough in numericals. Okay, now coming to the second important thing is parallel combination. Parallel combination. Parallel combination means here what will we do? We take two or more resistors and we connect them across the same terminals AB. All R1, R2, R3, all are connected across same terminals. So keep the animators A1, this is A2, this is A3 along with their branches like this. Now across this AB we connect with the electric cell. Our battery should be connected with V volts. And by means of tap key, here ammeter, and it should be connected. Across the terminals AB, what is the potential difference applied across the combination V? All resistors will have a same potential difference. Features, all resistors avail same potential difference. All are provided the same potential. And finally, what is the currents? If you observe, currents will be different. Here it is I1, this is I2, this is I3. Total current is I. So we observe second important point. I1 is taking place in accordance with V by R1, Ohm's law. Every time current will be decided based on potential difference applied and resistance provided. So second I2 is given by V by R2 and I3 is given by V by R3. The total I, let the total combination is offering the resistance. Total combination is offering the resistance I, then I must be equal to V by total resistance R. But we can see from all these readings, the third important feature is I is equal to I1 plus I2 plus I3. Therefore, substituting these values, we get V by RT is equal to V by R1 plus V by R2 plus V by R3. Therefore, 1 by R is equal to reciprocal of total resistance is equal to sum of the reciprocals of individual resistances. This is very very important third feature. What happens when resistors are consumers? Bulb, AC, refrigerator, and whatever the consumer is taken. If all are connected in parallel, they will avail required power. All will work with full capacity. That is why parallel combination is advantageous. The total power, here also the total power drawn will be equal to P1. Here it will not be shared. Total power, if three resistors are connected in series, then power consumed is less when compared with when they are connected, same combination is connected across parallel, we get the maximum power utilization take place. All gadgets will work with maximum capacity. So the power consumed will be maximum. Because here P1 is equal to I1 square R1. P2 is equal to I2 square R2. And P3 is equal to I3 square R3. Likewise, the total power consumed will be very very high when compared as these all resistors are connected in series combination. Here who will consume more power? If I connect 10 ohms and 50 ohms connected in parallel, then who will consume more power? Here less resistance will consume more power because all are provided with same potential difference. Therefore, lower resistance because power consumed here depends on V square by R. Here also you have to take V square. Here what happens, instead of I1 and R2, you have to express them like this. P1 is equal to V square by R1. P2 is equal to V square by R2. P3 is equal to V square by R3. Smaller resistance consume more power. So total power P1 plus P2 plus P3 is equal to how much it will become? V1 square V square by R1 plus V2 square by V square by R2 plus V square by R3. That will be the total power. Total power, whatever it happens, V by RT square. V square by RT is equal to V square by R1 plus V square by R2 plus V square by R3. This formula should be noted here. So, what will we recommend in household electric circuits? We recommend to make every gadget work with full capacity. That is only possible in parallel combination. So, series combination cannot be suggested in household wiring. This aspect should be carefully, addressed. Therefore, these are the important combinations. And finally, we are familiar with the heating effects of electric current. When current is passed through the conductor continuously, what happens? These electrons will be dribbling across overcoming the attraction of atoms. In this dribble, what they will do? They collide with the ion core and produce heat energy. Heat energy will be produced when electrons are making their passage through the conductor against the attraction of or opposition caused by atoms. What happens? The total energy will be converted into heat energy due to this friction. So, Joule's law of heating effects of electric current should be carefully familiarized. What is Joule's law of heating effects of current? The current, electric energy produced, W is equal to VIT is equal to I square RT or V square by RT will all be converted into heat energy. So that heat energy is what Joule discovered. That during passage of electricity through the conductor, most of the electric energy is converting into heat energy. So H is equal to VIT, you can write, or I square RT. So how it happens? So H is directly proportional square of the current, and H is directly proportional resistance of the conductor, and finally H is proportional to time taken. So Joule's law of heating effects of electric current. In every wiring, as current is flowing, some heat energy will be produced. Due to this only, we are observing the heating of electric circuits. So to avoid this excess of heating, what will we do? The electric iron is working basing on the heating effects of electric current. Similarly, electric bulb also working on basing on heating effects of electric current. So electric energy is converting into light energy and heat energy. In electric circuits, if you allow this heat to be produced continuously, it may lead to fire accidents. So to avoid the excess flow of current, we have produced the important gadget that is called fuse. You have to explain every child the application of fuse. What it will do? It will present along with the all gadgets in series. It will also produce heat. After a certain point, what happens? If excess of current flows, fuse will melt and break the circuit. Fuse is a important gadget. This is the symbol of fuse. It is made of conductor, lead and plus tin combination, which is having low melting point. Low melting point is desired for fuse. For different gadgets, we have different fuses available. You are familiar. AC will have different fuse, and a washing machine will have different fuse. Means what it will do? It will allow only the required current. If excess of current is taking place, immediately it will heat up and melt down and break the circuit and causes the alertness that something is excessively flowing. So we have to carefully check this insulation and check all aspects. Any drawbacks are there. Short circuits also may take place. So fuse is very important. Joule's law of heating effects of current is helping while converting the electric energy into heat energy, electric bulbs are exploited, electric iron and other important heating elements, heating gadgets, and finally fuse is also based on working on basing this Joule's law of heating effects of current. So this type of build-up is to be carefully familiarized, how electric circuit is prepared, combination of electric circuits and their important features, how Joule's law of heating effects of electric current is to be exploited. That is to be carefully thorough. And finally, third important point, change the question differently and make student to answer, respond carefully, accordingly. Finally, fourth point, make the student to write as it is given in the textbook. Don't allow them to write as their own, on their own, whatever they know, higher knowledge. Only they should limit on the textbook information. And fifth important point, plot the diagrams neatly and make the examiner impressed. Finally, your evaluation should be careful. You should be very careful and in mentioning the drawbacks of topper, whether he is writing the total information or missing anything. If he is missing, student is missing, your responsibility to alert them carefully until they succeed in getting 600 or 600. So I wish you all the best. Thank you very much.